Welcome back. We are at Module 6 of the Machine Learning course with Python Tray. In this module, we discussed a number of feature selection and model selection strategies. We are at lesson 9. We are going to discuss about a technique called linear discriminant analysis or LDA. What are the fundamentals of LDA? LDA is a supervised learning algorithm. It can be used for classification tasks also. Here we are really concerned about the dimensional reduction. It is also a dimensional reduction technique. It projects a data set into a lower dimensional space. Suppose the number of dimensions is 3, it will project to 2. If it's 2, it will project to 1. So it reduces dimensionality while maximizing the class separability. Okay, it's very useful in classification. So in the case of PCA, it is similar to PCA, but PCA, it maximizes the variance, doesn't bother about class separability. But LDA, while it reduces the dimensions, it also improves the class separation. LDA is also known as normal discriminant analysis, ND, or discriminant function analysis, DFA. It's a different name for LDA. What are the applications? Image recognition, like facial recognition, fingerprint recognition, and so on. Predictive analysis in marketing. What is the cost of the sale price of a house? Pattern recognition, used in medical diagnostics, studying the different patterns. The goal of LDA is to find the linear combination of features. See, very important, linear combination of features. So the original features are lost, you get new features like in PCA. But it's a linear combination of features that best separates the classes in data set. Two objectives. One is it reduces the dimension by combining features linearly. And it also increases the separation between classes. Look at the figure. The x is the independent variable or feature. So all these features are projected to this line, this axis. So, and the most important is the distance between this class of features and this class of variables are quite distinct and wide. That's the important lesson you have to learn from LDA. It tries to separate the classes clearly. At the same time, it reduces the dimension. Can also use for classification. So similar to PCA, it generates new independent variables. Not the word new, but also new dependent variables. In PCA can only do for independent variables, but LDA can do for dependent variables also, the Y's. Both are lower dimension, but equally good accuracy. Like PCA, LDA is also used in data preprocessing step for pattern classification. As a goal to project a data set onto a lower dimensional space. We saw that. In addition to finding component axis, the line which is going like that, we find the axis that maximize the separation between the classes. The goal of LDA is to maximize the separation between the classes so that you don't have any confusion. Technique of new feature extraction from n independent variables to p less than n, new independent variables. So basically it reduces the dimensions. Both PCA and LCA, they reduce the dimensions from any number to 2, not 3. So PCA finds the component axis that maximizes variance. This is an important point. It maximizes variance. Doesn't care about separation of classes. LDA so PCA is used for clustering also. The clustering modeling also use PCA. LDA maximizes component access for class operation. Data can be recovered from new vectors in LDA. What are the steps? Of course, these steps I give you, you can read the literature to find how to do actually. We will develop LDA modeling using LDA in the Jupyter notebook. So that makes it very easy. You won't understand what's happening. This is what happens. So compute d-dimensional mean vectors for different classes from the data set. Compute scatter matrices in between class and within class. Compute eigenvalues and corresponding to eigenvalues lambda 1 and lambda 2. So compute eigenvector corresponding to eigenvectors. Sort the eigenvectors in descending order and choose k eigenvectors. Use the k eigenvector matrix to transform the samples of the units of space. So we are going to take the same two examples we saw of PCA, the same data set, and we'll carry out LDA. Okay. So, but most of the program are same. Only changes are in the code for dimensional direction. So you substitute the original code by from sklearn discriminant analysis import linear discriminant analysis as LDA. So LDA is equal to n components equal to 2, like in PCA. And we modify x train xs. The total x we transform. Okay. So why we don't touch? Okay. So the x train and y train. Okay. And the x train and y train. X train and x test will be new, derived from the existing fixtures. Now let us get into how to carry out LDA. Okay. We will use the Jupyter notebook. We will choose the Jupyter notebook. We will first do for name base using name base classifier. We are going to see for the name base classifier. Okay, this we already saw that. See that with PCA. So you are going to import the libraries numpy as np, matplotlib as plt, pandas as pd. These are same data set minus data set CSV that you assign to data frame data set. And the head is printed here. The first 5 rows are printed here. See the number of columns there, number of features. Finally, we will have only 2 features, 2 combination of features. 2 features only, finally. They are not the original features, but the modified or derived features. So here what we do is we allocate columns 1 to 14, 1 to 13 to x and 0 for y. This is 0 the class. You remember the purpose is based on these columns. We find out which class of users will like those weights. Only 3 classes, 1, 2, 3. So the column 0 is the response variables, and all of those are the features or independent variables. So we do this, run it, and we got x5 and y5. So all the y's are ones. In this case, the heads they have ones. Then we carried feature scaling. Same code, no change, so I won't explain much. Speed scaling. Now we are going to split the data set into training set and data test set. It's also same old code, so I'm not going to explain. We have 178, x and y's, which we divide into x train, x test, y train, y. 142 will be assigned the x train, and similarly y train will be 142. So 36 will be x test. So then without carrying out LDA, we classify using A-based class. This code is all same as old one. You know it. NB classifies with X train, Y train. NB classifies with class in NB, all that. Then import for SQL and neighbors, import Gaussian NB. Okay. We also import metrics. So we get accuracy of 0.916. Now we are going to carry out linear discriminant analysis. So what we do is from SQL and discriminant analysis, import linear discriminant analysis with LDA. So n components will be true, so we will get only two features. Now with these two features, you carry out neighbors. So these are two features which contribute to the maximum to the response. So you get accuracy of 0.972. So the response really here improves. The accuracy really improves. So what we have done is we have initially carried out neighbors classification with the original data, original features. Then we carried out linear discriminant analysis in this portion. Then we used those two variables and carried out the neighbors classification. Now we have done one example. We'll take the same other example and we carry out SVM. Okay, we carry out SVM with the same data set, and that's same, only one modification you're making. So SVM LDA, these are old code, so no need not explain. And the data frame, you know it, the points data, and x5, y5, you know it. So fixed scaling, same as all. I'm standardizing the whole thing. Fixed scaling everywhere will be the same code. And similarly splitting this data set into training set, data set, training and test set will be the same code. So I carry out SVM with the original features, that is 13 features. And we get accuracy of 1.0, very amazing, because we are using Gaussian, we are using RBF kernel. So that's why the accuracy is too good. Now I change the code for PCA, I put linear discriminant analysis, for scalar discriminant analysis, import linear discriminant analysis, LDA, n components per 2, and x train and retain the fit transform and transform. Note the x train is linear or fit transform, x train, y train. X test is LDA transform x test. So do this. We have got two features, new features, and carry out classification using SVM. And we get accuracy. So accuracy, of course, the highest is 1. So accuracy is not affected, but it will help you to control, the overfitting. 1.0 is a little overfitting, but then it's a safe for test and this is for test. Accuracy 1.0 is for Y test, Y prediction. For testing. Here again, this is for Y test, Y prediction. In the test 1.0. So it controls the variance, it controls, it will improve generalization of the model for new data. So what we have done is, I explained to you what is LDA, another dimensional direction technique, whose aim is also to improve the separation between classes. And I gave you two examples. One example, we carried out LDA and fitted naive-Bayes classification. The second model was support vector machine, and we carried out LDA and we carried out LDA and fitted the model. I hope it's clear to you. I would urge you to go through the program, do it yourself in your computer. I hope you are doing it. Thank you for watching. Thank you for your time. Until we meet again. Bye-bye.